Okay, we're learning the derivatives of logarithmic functions today. And we are learning uh, additional new derivative formulas. So today we're learning two formulas. It's again really just one formula, but we also do a special case where the base is e. So our formula is that the derivative of a logarithm is 1 over what you're taking the logarithm of, x, times the natural log of a, where a is the base. So for example here, if y equals the log base 2 of x, then the derivative is 1 over x times the natural log of 2. And in the special case where your base is a base e, remember here I have natural log of x, and natural log of x is just log base e of x, then the derivative is 1 over x times the natural log of e, because the formula tells us that we times by the natural log of the base. When the base is e, well, the natural log of e, this just here is just 1. And so our answer is 1 over x. And so, for example, if y is the natural log of x, then y prime is simply 1 over x. And that's our new formula. And so to date, we have three formulas. Well, we have a lot of rules, but we have pretty much three formulas. One is the power rule, which says that the derivative of x to a power is nx to the n minus 1. Our second rule is that the derivative of a base of an exponential function where x is the in the exponent, then that derivative is a to the x times the natural log of a. And now this is our third rule, that the derivative of the logarithm with a base a is 1 over x and then natural log of a. All right, so let's do some practice using this new rule. In number 1, f of x is the natural log of x cubed plus 5. And I'm going to take the derivative of f of x. So my rule tells me that the derivative is 1 over the inside. 1 over x cubed plus 5. Now, this isn't the end of the derivative. I would multiply by the natural log of the base, but the base is e and the natural log of e is 1. So that's not why this isn't the end. The reason why we're not done yet is because my inside has a derivative. And so I'm going to use the chain rule. We have to always be using the chain rule. And so I multiply by the derivative of the inside, and the derivative of the inside would be 3x squared. I'm using the power rule there. And so the derivative here is 3x squared over x cubed plus 5. All right, now let's move on to number 2. I'll do number 2 in blue. Here I have the log base 5 of a quotient. All right, so let's take the derivative. If you look at this function, I do have an outside. The outside is a logarithm. And the derivative of a logarithm is 1 over the inside. So I'm doing 1 over x over x plus 1. My base is not e, my base is 5, so I multiply by the natural log of 5. So this is just simply using my logarithm rule for derivatives. Now I'm going to use the chain rule. So I'm going to multiply by the derivative of the inside. I'm going to call the inside u. And I'm going to multiply here by whatever u prime is, because that's how the chain rule works. We multiply by the derivative of the inside. Okay, so u is a quotient, so I need to use the quotient rule. I label the top as f and the bottom as x plus 1, f as g, and I find f prime and g prime, and so the derivative of u is f prime g plus minus fg prime over g squared, because I'm using the quotient rule. And again, all of this green work here, this is side work. And so my derivative of this quotient inside is 1 times x plus 1 minus x times 1 over x plus 1 squared. And so the x's here would cancel. And so I have 1 over x plus 1 squared. That's my u prime. So that's what I multiply by. I am going to clean this up just a little bit. Notice that one of these x plus 1's here, I have one big fraction, and in this denominator of this fraction, I have x over x plus 1. You can rewrite this so that this is x plus 1 over x, like that. Or at some point we need to cancel on x plus 1, because you have an x plus 1 in the denominator of the denominator and in the numerator of the denominator right over here. And so an x plus 1 needs to cancel. So let's cancel that here and not do this. So then I have that my derivative, I just have 1 in the numerator. I have x, ln of 5, and x plus 1 in the denominator. And that's a 1. All right, so that is the answer for number 2. Moving on to number 3. Here f of x equals e to the x times the natural log of x. And I have a product. This would be f, and that would be g. And so f prime would be the derivative of e to the x, which is just e to the x. We learned that yesterday. And the derivative of g prime is 1 over x, the derivative of natural log of x. And so now I'm going to use my product rule, which tells me to do f prime g plus fg prime. And your book would factor in e to the x out, and we have left natural log of x plus 1 over x. All right, the last one on this page, we have something very, very complicated. This question could be really, really tricky. It could be several chain rules. I'm not going to do it this way. I'm just going to show you something. If I did this right now, which I'm not going to do the derivative this way, I'm going to show you how to simplify this first. But if you don't do any logarithm rules or don't know your pre-calculus logarithm properties, then this is a very difficult, ugly question, because you have to start with a lot of chain rules. You have to do the derivative of the outside, so that's 1 over the inside. Okay, then you need to multiply by the derivative of the inside. Well, the inside is a product, and so you have to do the derivative of the first one, which involves a chain rule, times the second one, and then plus, and so there's a lot to do here. So we're not going to do it this way. Instead, I'm going to show you that this logarithm, you can use log properties and make this question much easier. Not long ago, we reviewed the log properties. And if you have the log of a product, a times b, then that's just the log of a plus the log of b. And so this, notice I'm not labeling this g prime, this is g of x. G of x is just the natural log of 2t plus 1 to the third plus the natural log of 3t minus 1 to the fourth. So I've used my sum to addition log property there. Also, we have a power rule for our logarithm properties, which tells me that I can take this 3 and just move it to the front. Remember that property? You can put exponents in the front. That's one of the ways we solve. It makes things simpler. So this is 3 natural log of 2t plus 1 plus 4 natural log of 3t minus 1. This g of x is a much easier version to take the derivative of. And so I will take the derivative here, and I have no product rule to do. I have a couple chain rules, but they're not difficult chain rules. So this 3 is a constant multiple, so we have 3 times. The derivative of the natural log part is 1 over the inside. Now the inside, 2t plus 1, has a derivative, so I multiply by that for the chain rule. And so this is the derivative of the first term. Plus, now I'm going to do my second term here, 4 times the natural log of 3t minus 1. That would be 4 times 1 over 3t minus 1 for the derivative of my natural logarithm. And then times the derivative of the inside of the natural logarithm, 3. And so this is a nice simple 6 over 2t plus 1 plus 12 over 3t minus 1. No ugly exponents, no product rule or any crazy chain rules. It was a very straightforward problem as soon as I wrote g of x this way. So be on the lookout for those. In my next example here, I have to find the first and the second derivative. So let's start with our first derivative. Notice this is a quotient, and so I'm going to do the quotient rule. The quotient rule says to do the derivative of the top times the bottom minus the top, no derivative, times the derivative of the bottom, and then divide by the bottom squared. Notice that I have done the quotient rule for you here, but I have not labeled my f, g, f prime, g prime. You do eventually want to stop doing that. But do it whenever you're comfortable because it's a lot faster. So this is x squared minus 3x squared natural log of x over x to the 6th. I'm going to factor an x squared out of the top. Then I'd have 1 minus 3 natural log of x over x to the 6th. This will cancel. I have now just 4 x's in the denominator. And this is much easier to take my second derivative of. I would tell you to do this by yourself, but I think I have shocked you yesterday with the second derivative, so I'll do this one for you again. All right, my second derivative is the derivative of the top. Now, if my top is f, then what's the derivative of this? Well, the derivative of 1 is 0 minus 3 times the derivative of the natural log of x, which is 1 over x. So this is negative 3 over x times the bottom minus the top, no derivative, times the derivative of the bottom, all divided by the bottom squared. I'm going to simplify this just a little bit. This is negative 3x cubed and for this term right here. And now on this second term with the minus fg prime, I'm going to go ahead and distribute my minus at the same time as I distribute my 4x cubed. So that's minus 4x cubed plus 12x cubed ln x, all divided by x to the 8th. Go ahead and collect your x cubed terms. That's negative 7x cubed. And factor out an x to the 3rd and cancel it. We have negative 7 plus 12 ln x. Canceling, that makes that a 5. So your final second derivative is negative 7 plus 12 ln x over x to the 5th. All right, we have one last example to do here. The natural log of x squared minus 4 over x minus 1. We need to use the quotient rule here. That top is not easy to differentiate, so I'm going to go ahead and label here. So 1 over your inside times the derivative of the inside. Oh, that wasn't that hard. Now the derivative of the bottom is just 1. And so for my derivative, using the quotient rule, the derivative of the top times the bottom minus the top times the derivative of the bottom, 1, divided by the bottom squared. This must be an example because I'm going to show you how to get the answer in the back of the book now. Okay. In the top, let's get a common denominator of x squared minus 4. Notice I distributed my 2x to the x minus 1. that would be 2x squared minus 2x. And then to get an x squared minus 4 in the denominator here, I have to multiply it to the natural log also. And then that would be divided by the bottom, the original bottom. And so now in the top I have the one fraction of 2x squared minus 2x minus x squared minus 4 natural log of x squared minus 4 all over x squared minus 4. And then you would multiply that by the reciprocal of the bottom. So that's 1 over x minus 1 squared. And your answer in the back, I think, would look like, yeah, this is just not that pretty of a question. I'm thinking this is what they would write. This is what I would write. And that's it.